Today we will talk about particle nature of matter. If we see matter around us, solid, liquid or gases, if we could see inside, will it be continuous? Will we find all space filled up, or will we find small particles in between blank spaces? This is a question which has troubled people for thousands of years, and for a very, very long time people believed in one or the other theory without any proof. But today we look at it as the particle nature of matter. We believe that matter is made up of particles. Water expands when it turns into steam into a very, very large space where particles spread out, leaving spaces in between. So today we believe in the atomic theory that all matter is made up of nearly 100 types of atoms which are different from each other in size, weight and properties. And these atoms can remain single or join up together to make molecules. So either same ones join up together or different ones join up together and make molecules of different kinds, which creates our world of all materials. So how do these atoms and molecules behave? This is the kinetic theory of matter, which tells us a large number of things. Here we can imagine water molecules as made up of one oxygen atom and two hydrogen atoms stuck to each other. And how will these molecules behave? We will see further. Here we are seeing actually a special picture of molecules in a solid arranged in a very neat structure. This picture is taken in a very, very sophisticated lab using specialized techniques. These molecules are too small to be seen with any instrument. Now, here is something we see that if this is smoke, which is a gas having some solid particles suspended, we see constant movement. So these particles in matter always move. They are never still and they move haphazardly in random directions. So even in a liquid, if we put a drop of color, we see it going randomly in all directions. So particles always move and their movements are different in the three states of matter. So if we see, here we see a solid. I hold a solid at one end and pull at it and the total solid comes with me. So which means the particle inside these solids must be tightly attracted to each other. They must be stuck to each other. That's why I can pull the whole solid together. Can I do that in a liquid? If I try pulling the liquid together, all of it does not come, and gas is not possible to pull at all. So the attraction between the three states, the particles in the three states of matter are different. So we see some evidence of all this from our daily observations. We will see that if I put my finger inside a solid, my finger does not go in, which means the solid particles are strongly stuck to each other and do not allow my finger in. But in a liquid, I can actually put my finger inside and move it, which means the liquid particles are attracted, but they can slide and slip past each other and give my finger space. In a gas, I can freely move my finger. So similarly, so this is the arrangement as it is imagined, that solid particles are arranged in a very neat fashion where they hold their positions tightly and tightly attracted to each other, and they vibrate about their mean position. They move, but they do not leave their positions. So they vibrate about mean positions. Here you can imagine solid particles inside a bigger particle, let's say an atta particle. So these you can imagine as molecules inside an atta particle, too small, very, very small to see, but then they are having their fixed space and moving about their mean position. So this is how we imagine solid molecules behaving. Now, if we see liquid, so liquids are moving much faster and they are slipping and sliding past each other. They are not tightly bound to each other, and therefore liquids can flow. They can flow, they do not have a fixed shape, and they can even take the shape of the container in which they are poured. Because of this property to slip and slide, they have attractions but not very strong attractions. So they are moving about. And in a gas, there are very little attraction, there are large spaces in between, and gas particles move freely till they bump against another particle or bump against the boundaries of the container. So each gas particle moves in a straight line till it bumps against the boundary and turns back. So each particle will freely move like this. So gases can actually fill up a large amount of space because there's any amount of space between the particles. So the three states of matter, their particles are imagined like this, their movements are imagined like this: solid, liquid and gas. And the understanding of attraction between them and their movements tell us a lot about their properties. For example, here we are showing liquids coming down in drops. So this means that a very large number of liquid particles are actually attracting each other to create a drop. The particles are not coming separately, they are coming down as drops or streams, which means they are showing some attraction. If we pour them down, the particles are pulling each other to create a stream, and that's why they are dropping down together. And this tendency to come down as streams or go with other particles, we can see through an experiment also. If we take a smooth sheet and we pour some liquid over it, so the liquid drops and stays together in the form of a drop. And now if I pull at one side of this drop, I pull it slightly and I see the rest of the liquid following, which means particles are attracted to each other, they are following each other into any direction that I take the first ones. So this shows attraction between them.